Welcome to the next part of the Taylor 65B restoration, and I'm pleased to say actually this is going to be the final part. As you'll see a little bit later on, I've finally got it all working, and in the end you'll be able to see it in use, injecting a signal through the IF strip of a radio. So that's good news, and let's get to it. Well, here we are with the Taylor 65B, and the new capacitors have arrived to the RF oscillator circuit, so I'm going to fit those. They're a little bit fiddly, one's down in there and one's around the corner, so I won't bother filming that. But I spent a little bit more time with them. What I have discovered is that the 5 wave bands, the 300 to the 900 kilohertz band actually works fine and oscillates with a reasonable sine wave all the way across it. The band that goes from 900 kilohertz to 2.7 megahertz works fine from 900 kilohertz, but the wave, well, it simply stops oscillating at about 1 megahertz, and I can't really detect any oscillation in the other 3 bands. So I'm hoping as a starting point I might replacing these capacitors might do the trick. So we'll see how we go. Okay, a little more progress with the Taylor 65B. Last week I had a look at the resistors. It's really difficult to see, they're actually underneath. This is the RF oscillator valve, and that's the triode there, and underneath there's a couple of resistors soldered across some of the connections on the valve base. And last week I got access to that by removing various bits and pieces, checked the value of the resistors, and the 47 was a 47k, which was about nearly 40% high, and an 8.2k, which was about 30% low. They were 10% tolerance resistors. So I've this week got some replacements of a similar wattage, and I've put them in. The plan being to just slowly replace parts as I go along. So I've made some progress. Last week what was happening, if I just turn it round so you can see the face, when I was on the bottom scale here, 100 to 200 kilohertz, no oscillation at all. I was getting oscillation on the 300 to 900 kilohertz. And then above that I wasn't getting any oscillation on the higher bands, so I thought, right, I'll try replacing those 2 resistors for a start, which I've done this morning, and hasn't really had too much effect on that. But what was baffling me was the fact that the second band was working but the lower one wasn't, and I wondered if the lack of oscillation higher up was based on components being out of spec or worn out. But I noticed last week, and it's really difficult to see with a video camera, but that middle coil there, that is actually the coil for the low frequency band, and there's a very fine wire there, very fine. You can't see it. I've taken some stills which I'll superimpose on this video, and it was actually attached to that little bit of wire there, but I noticed it was actually broken, and I hadn't really noticed it before. To be fair, it's a very fine wire, so not easy. So what I was able to do was carefully tin the end of it, and I've now soldered it onto there. And the good news is that's instantly restored oscillation in band 1. So I've got it attached to the oscilloscope as a bit of a crude measurement of frequency. I'll just move up so you can see the scope there. So I've got sine wave now, and on that band, if I tune down to 100 kilohertz, I'm getting roughly 100 kilohertz according to the oscilloscope, and then it's pretty good right up to that's 200 kilohertz, and I'm pretty much bang on there. Slightly higher up at 250, it's starting to read about 5 kilohertz out, so the top end of the band isn't as good, but it's tracking pretty well from there. I had to adjust that with these trimmer caps on the back. That's band 1, but I've also had success with band 2 as well. So on band 2, which is 300 to 900 kilohertz, that's the 900 kilohertz end. That's actually a little bit like the other band, a little bit low, but once you drop down to say 600 kilohertz there, that's pretty much on the money. I actually tuned it with the capacitor at 500 kilohertz, as one of the things I probably want to do with this eventually is use it to generate a 455 or in that vicinity signal for aligning IF stages, and so at the 455 mark there I am indeed reading just about 460ish, and then if I bring it down to 300 at the bottom, it's about 4 kilohertz out, so not bad at all. So I'm encouraged by that progress. The attenuator is working well, as you can see there. I'll just reduce the signal, and turning that up full produces nice powerful signal, so that's good. So I'm not at all sure why the higher bands aren't working. I don't know if that's a problem because the valve is very old. I think what I might do is try and get hold of a replacement valve and see if that does the trick, as most of the other components have now been replaced. But what I am going to do before I do that is I'm going to have a good look at the other coils, see if there's any broken wires. If I'm honest, I doubt that, because the higher the frequency, the less turns there are on the coil, and I think it's unlikely I'm going to come across broken wires like I did there, because they're not as exposed. So there we go, a little bit of progress, and it is generating frequency, signal at a frequency which is pretty good for the type of equipment that it is. So great stuff. Okay, well I've just unsoldered one end of that resistor and that resistor. Those are on 2 of the frequency band coils, and just checked the values, and actually they're both very close to what the colour code says they are, so which is good. And I've switched the machine back on, and just decided I would try measuring the oscillation on the plate, well, there's a capacitor on the plate of the RF triode oscillator circuit, and I've just gone beyond that, so I've effectively the other side of the DC plate voltage, and just happened to be flick onto band 3 and noticed I'd got oscillation. So I've gone back onto the output, and obviously that little bit of soldering and desoldering has maybe disturbed something, I actually don't know, but I've now got band 3 working as well. So I've just tweaked it up here, and 1.5 megahertz or 1500 kilocycles, as the dial likes to tell me here, I'm now pretty close to 1.5 megahertz, 1500 kilocycles according to the oscilloscope. So a little bit of surprising but nonetheless pleasing progress. So just 2 bands to go now. Okay, well, happy to report some success, in fact 100% success. Machine's just sitting here now, oscillating nicely on all 5 bands. I took the connections off this coil here and checked continuity, and checked if I could measure the inductance, which I could on one of them. That was all fine, so soldered it back on. Checked the continuity to this trimmer cap, and that seemed okay. So then I just tried tweaking the actual trimmer, and lo and behold, it burst into oscillation. I don't know quite what it is. It's probably a poor connection on the threaded section there. Maybe it is as simple as that. It's just years of build up of grime and stuff. But I've worked that a few times, and I've now tuned it. So I'm now very pleased to report that she's sitting there on 13 megahertz, and no, I'm talking rubbish there. It's it's sitting there on about 4.5 megahertz, and indeed that's what the scope is telling me as well. So that's really good. So it looks like from an electrical point of view we're sorted, which is absolutely great. So I'm going to switch it all off and put it back together, and then give it a proper trial when it's back in the case and see how she goes. Okay, well, I've got everything back together. All 5 wave bands are working, which I'm very pleased about. Now, there was certainly room here on the front panel to replace the original socket with a BNC. That would have been very easy, but when it arrived, it actually came with the original plug, which I suspect is probably quite hard to come by now. So I've cleaned it up to try it, and sure enough, it actually works fine on the original plug. So what I'm going to do is, now I know that's okay, I'm just going to clean the body of the plug up, put a little bit of heat shrink over to support the cable, and remake the ends. As you can see, they're a little bit rusty. So I'm going to remake those ends, and I can use that as the cable to use the unit. And actually, it is actually quite nice to keep it original. Fitting a BNC would be easy, but wouldn't quite be genuine. So absolutely delighted with that. Restoration pretty much complete. I need to get a few nice shiny screws to replace the somewhat rusty ones that came out, but I'm going to get it back in the box now, and hopefully I'm going to make use of it for my new project, which arrived yesterday, which is another piece of valve equipment, and it's in quite a bad way, so that's going to be a challenge, but hopefully I can use this to help me get it working again. So that's good. Taylor 65B, 1940 signal generator, back and working, and hopefully going to give some good service. Okay, well, here is the Taylor 65B back in its case. Still need to get a few screws, probably get some brass screws just to tidy it up, but she's fully working. I've redone the old lead, so I'm using the original connector there, and she's switched on, warmed up, and currently on range tooth, which is 330 to 900 megacycles. And here I've got a Russian VEF 204 receiver, which I know has got an IF it's a single superhead with an IF of about 460 kilohertz. So we're just going to see if she'll do what she was designed for. So if I sweep across, just simply got an RF signal now with no modulation. I've got the volume turned up. I've got it connected to the antenna input. There is a capacitor in there isolating that radio from the mains, so I'm not too worried about using the capacitor there, which I probably would normally would. So I'm going to sweep across. And there you can hear probably very faintly hear the signal. So I'm just going to centre that. In fact, the Taylor does indeed have a mark for intermediate frequency, so I'm right on there now. And you can maybe just about hear the hissing sound. I'm now going to turn the internal 400 cycles modulator on, and hopefully you'll be able to hear the tone too. There we go. So she's all set up, ready to align the IF, and hopefully good for a few more years yet. So good stuff. Hope you've enjoyed watching the restoration. Pleased to have got it working eventually, and was definitely worth the £25 I paid for it when I bought it. Sold as not working. In actual fact, it was partially working, but needed a fair bit of work doing. If you like the video, please click the thumbs up, and it'd be great if you could subscribe. That'd be a good help. And of course, I couldn't have done any of this without lots of other YouTube channels that provide such good information, and I'm going to put some links below to those channels, and I'd thoroughly recommend you visited them. But there's some real good stuff out there. I'm just an amateur. These guys are, well, they're probably, some of them are probably amateurs too, but they're certainly operating at a professional level. It's just great and impressive to see. So there we go, nice to see something brought back to life. Thanks for watching, and don't forget to like it, if that's assuming you did.